Many properties of the liquid can be determined by the strength of its intermolecular forces. And here we're going to talk about three different properties of the liquid stage: surface tension, vapor pressure, and viscosity. Now, what is the surface tension? It is the measure of the resistance of a liquid to spread out. Now here, let me draw a quick diagram here. For example, here this is a container as a liquid here, and we know the surface of a liquid looks like this, which we call it as meniscus. Now the particle that's present in between here in the inside its interior of a liquid is surrounded by the particles from all the sides and experiencing these intermolecular interactions. But the molecule which is present at the surface is not experiencing the forces from all the sides. In fact, it's just experiencing from just its neighbors. So here the molecules are, and they're pulling these molecules present at the surface inwards. That's why the surface of a liquid looks like this. So the stronger the intermolecular force, the stronger surface molecules are pulled down towards the interior of a liquid and higher the surface tension. So let's take two examples, water, and let's take acetone, CH3COCH3. So water has London dispersion, dipole-dipole, and it also has hydrogen bonding, while acetone has London dispersion and dipole-dipole. So which one out of these two has stronger intermolecular forces present? Water. So that means water molecules, or the water molecules present at the surface of a liquid, will experience more surface tension. Means the molecules present inside, those molecules will pull the molecules present at the surface with the higher surface tension. Similarly, the next one is the vapor pressure. So let's say we have a container, it's a closed container, and we have liquid in it. And what's happening with the heat, this liquid particles are changing into the vapors. But since it's a closed container, so these vapor particles eventually condense back to form the liquid. Now, so when these molecules, the vapor molecules, change back to the liquid, that's a condensation process, and the opposite one, when the liquid molecules are evaporating, is a evaporation. So when the rate of evaporation, means liquid changing into the vapors, is equal to the rate of condensation, means the molecules, the vapors are changing back to the liquid, they're equal, we say it's at equilibrium. So let's talk about these vapors. The vapors are gaseous particles, and what does gases do? They exert pressure. So that means these vapors have vapor pressure, and this vapor pressure increases with the increase of temperature. If you start heating it, means you can make more vapors. So higher the temperature, higher is the vapor pressure. But let's see, if the very strong intermolecular forces are present between the molecules here in the liquid, will that be easy to change this liquid particles, liquid molecules to the vapor form? No. So that means substances with larger attractive forces, or the larger intermolecular forces, will have lower vapor pressure. So again, if we take the example that we took it in the last slide, water and acetone, water has hydrogen bonding while there is no hydrogen bonding in acetone. So which one is going to have the low vapor pressure? Water is going to have low vapor pressure, because the presence of strong, or the strongest intermolecular force, will inhibit the formation of vapor pressure, the vapors. The next one is viscosity. And what is a viscosity? It's a liquid's resistance to flow. A viscous liquid is one that feels thicker, and substances with larger attractive forces between molecules are more viscous. So, for example, let's take this example, uh, CH4 NH3. Which one is more viscous? So think about the intermolecular forces. CH4 nonpolar molecule just have London dispersion. London dispersion are present in all the molecules. There is no dipole dipole here, but there is dipole dipole here because nitrogen hydrogen electronegativity difference. There is no hydrogen bonding here, but hydrogen bonding is present here too. So these have NH3 has stronger intermolecular forces present as compared to CH4, so this one will be more viscous.
Made with Doodlecast Pro.